Welcome to the last unit of the school year. The last unit is on sine and cosine graphs, their identities, and how to use their graphs and what situations in real life they apply to. But to begin with, I'm going to go back into Unit 13 because there are two sections that I skipped. Section 13.2 and Section 13.3. I skipped them because I felt they would fit better with Chapter 14. So, Section 13.2 is on angles of rotation. We're going to talk about trig as well as circles, and we're going to put them together in this unit. So the first thing that we need to understand is what the unit circle is. I'm going to be dealing with the unit circle a lot throughout this unit. A unit circle is a circle that has a radius of 1 and has its center at the origin. So for instance, if I draw you a circle, not too bad. The center's roughly about right there. Putting this circle on the coordinate plane. So I'm going to draw some straight lines, hopefully right through that center. And I'm going to draw another straight line right through that center. This would be the x-axis, and this would be the, got to get out of the, got to get back to the pen mode here quick. This would be the y-axis. The center is, the center of the circle is at the origin, and it's got a radius of 1. That means this line right here, that I'm darkening in blue, has got a radius equal to 1. So therefore, for instance, this coordinate right there would be the coordinate 1, 0 in the coordinate plane. That is what the unit circle is. Now what we're going to do is we're going to talk about angles that are in standard position. Standard position is any angle whose fixed side is on the positive x-axis and whose other side can move. All right, so what am I talking about? Well, again, I'm going to draw in here. I'm going to try and draw some straight lines on this first circle. There's my y-axis, and this would be my x-axis, let's say. Okay. Now, this is x, this is y. An angle in standard position has its fixed side on the positive x-axis. So I'm going to draw the fixed side in red. Here's the origin. The fixed side is this side right there in red. It doesn't move. It's stuck there. The other part of the angle, the green line, can move. This can move and form an angle. Now, the initial side is the fixed side of the angle. The fixed side of the angle that is on the positive x-axis. The terminal side is the ray of the angle that can rotate. That's the green line. So the terminal side is the green one. The initial side is the red one. I hope that makes sense. Now again, I'm going to draw on the next circle. I'm going to draw my x and y axis through the center of the circle. And we're going to talk about angles of rotation now. All right, so dealing with angles of rotation. Positive rotation is when I'm going to draw this in red again. The initial side is right here, and my terminal side is there, and when you rotate in that direction, that would be called positive rotation. That would be counterclockwise. Positive rotation is counterclockwise. If I turned it this direction, that would be negative rotation. Negative rotation goes clockwise. So I hope that makes sense. Positive rotation is counterclockwise, like my green arrow. My blue arrow is negative rotation because it's clockwise. So make sure that you understand that. Okay, now let's talk about angles of rotation. Certain angles of rotation that we will be using. First of all, we need to understand that 0 degrees will always be on the initial side. So that would be 0 degrees. You're probably going to want to make this chart. My red line is my initial side. 0 degrees is always to the west. 90 degrees is always to the north. 180 degrees is always to the west. And 270 degrees is always to the south. My dotted lines are halfway in between. So halfway in between 0 and 90 is 45 degrees. Halfway between 90 and 180 is 135. Halfway between 180 and 270 would be 225. And halfway between 270, and obviously 0 is also 360, we have 315 degrees. Those are the dotted lines. Those are the multiples of 45. So I'm going to color code this. Multiples of 45 degrees. Those are in green. And they're dotted. Please do that on your paper. Now, the multiples of 30, degrees are going to be in blue, and those are the solid lines. So this would be 30 degrees. This is 60 degrees. We already have 90. This would be 120 degrees. This would be 150 degrees. This would be 210 degrees. This is 240. This one here is going to be 300 degrees, and this one is 330. The angles that I put on this wheel are the most important angles that we will be using throughout this entire unit on trigonometry and sine and cosine graphs. So make sure you draw that chart and make sure you keep that chart. All right, let's talk about coterminal angles. Coterminal angles are two angles whose terminal side ends up at the exact same spot. So for instance, let's say that I graph 135 degrees. So here's my initial side. I start there. It's positive 135, which is this green line over here. So this angle right here that I'm drawing in green is positive 135 degrees. What is its coterminal angle? Well, if I rotate it negatively to there, that angle is negative 225 degrees, because 225 plus 135 makes 360. So if I wanted to write this down, 135 degrees and negative 225 degrees are coterminal because they both end up with the green line at the exact same spot. I hope that makes sense. Now, here's an example for you. Let's say I asked you to name the positive and negative coterminal angles of 55 degrees. Well, I'm going to erase this. 55 degrees. Let's draw that. Here's the initial side. Positive 55 degrees. This is 45 here. This is 60. So 55 must be somewhere about right there. So there's my angle, 55 degrees. What would be coterminal to that? Well, first of all, this angle going this direction would be the negative one. Now, how do you figure that out? Well, you go 55 minus 360, because you're going from the green line all the way around. 55 minus 360 would be negative 305 degrees. That is my blue angle. Negative 305 degrees. That would be the negative one. How do you find the positive one? Well, all you do is take 55 degrees and add 360. So it's like going around again one more time, and that would equal 415 degrees. That would be the positive coterminal angle. So I hope that makes sense to you. That's how you find negative and positive coterminal angles. All right, last. Let's practice drawing. I want you to make the circle that you see here. And it's going to work out the same way as the other one. But what I want you to do is I want you to draw a 65-degree angle. Okay, hopefully you drew this. The initial side is always there. We know that this is 45 degrees, that dotted line. This is 60. So 65 degrees would be this green line right there with the arrow going that direction. Make sure you draw the arrow. Positive 65 degrees. So I color-coded that. Now I want you to draw negative 190 degrees. I'm going to do this in red. Well, hopefully you went to here, which is negative 180. This is 180. And then 10 degrees more would roughly be about right there. So if I continued that on, hopefully that would be negative 190 degrees, which would actually be on your wheel. That's the 170 mark. 170 plus 190 is 360. In black, actually in blue, I'm going to do this in blue. 420 degrees. Uh-oh, now how do you do that? Well, it's positive 420. Well, I'm going to start here. I'm going to go all the way around the circle. That's 360. So now what I'm going to do is just go 420 minus 360. I have another 60 degrees to go. Oh, so I'm going to finish right there on that line. So my arrow goes all the way around and then another 60 degrees. And there you go. That's the basics, people, to angles of rotation. Now the next video is going to be on reference angles.